Hello, college algebra student. This video is for chapter 4.3, fit linear models to data. So a lot of time data that we collect is not, especially if we have more than two data, it may not be linear. They could be scattered around. So in order to show the relationship between two sets of data, we use a utility that would let us to fit a best fit line. So they are not perfectly lined up as a linear unless you only have 2 points. If you have a lot of points, they don't. So we would graph something called a scatter plot to look at what model makes sense. Can I actually use a linear model? A linear model would usually show up when the points are, the scatter plot points are all lined up like close to a straight line. And so the first two are examples of a good linear model. When the slope of the line that they kind of trend along has a positive slope, we call a positive correlation. This actually just means when x increase, y also increase. X affect y to increase. Negative correlation would be when the trend line has a negative slope. That means when x increase, y decrease. So the meaning, like the wording of positive just mean x increase, y increase. Of course, it actually means you have a positive slope. Negative means that when x increase, y would decrease, and they affect each other. But if your scatter plot show like scattering around like with no pattern, then there's no correlation. You cannot use one to predict the other. So an example would be like this. If you call long distance phone call and time, so the more you call, the more money you pay. I think in the old day. And then this is a positive one. This one is time watching TV versus grade. The time you watch TV, your grade percentage drop. Okay. And although it is not strictly, so there's exception, everybody's different, and also your grade is affected by not just your time for watching TV, but other things, but they have a general trend. So we could say that is positive correlation and that is negative correlations. So in order to see if what correlation you have to do a scatter plot. We can do it with decimal. So the way you do it is you open up a browser window. And I'm going to open up a blank browser window. So those are the ones that I have set up. Go to decimal calculator, and then you will have a window where you are entering your graph that you want to graph, but we don't want to graph. We want to graph points, scatter plot. So what you do is you do a plus, you do a table, because table will show points. So your first x, y, the points are here. The second data, the x data or the y data, of course they have to be correlated like this from the same person. We call them match pair data in statistics. You cannot switch the x and y around because x affect y. This x, they comes in pairs basically. So let's go back to our. So that's what you do. You enter x, y, and then how do I get the line of best fit? The line of best fit. Let's just do an example. Like you enter these data like 3 and then 6, 6, 8, 4, 7. Just say, and then you can usually you would not see all the points, especially if they are like really big numbers, like 15, so it's far away, or 18, right? So the frame might not be there. So you click zoom fit, it would show up. Okay, zoom fit, and then you click the bottom. That's where you get your line of best fit. So the way you do it is you enter y1, but the one has to be underscore. So you use your underscore key on the keyboards to go down, and then you use the cursor key to go back up. The cursor right arrow, and then you need to enter a wiggly wiggly symbol. So if you can't find the wiggly symbol, it is under the keyboard ABC at the bottom. It doesn't show up in my frame. So here, oh, maybe I'll put it, maybe I'll extend this a little bit so you can see. So this is where the wiggly thing is. And then you will say M x1 x underscore 1 come back up plus B. If you enter this, then the line of best fit shows up. M is this, and the y-intercept is this. So they don't show up here. They will show up as they tell you what M is and B is. So that's basically how you do it. So let's go back to our notes. Let's do an example. So this is the example. Draw a scatter plot for the data below x, y. Just they don't tell you what data it is. Does this data appear to be linear related? So the first thing you draw a scatter plot is don't find the linear equation yet, but look at it. Are they linear? Are they positive or negative? Or is there any correlation? If there is a correlation, find the linear regression equation. The linear regression equation is more a statistic term. So the actual term is best fit line. So let's just do this. I have already entered this in a window here. I have a decimal open and I enter it before. Is it this one? No, X, Y. No, this one. Yeah, 5, 6, 10, 12. 5, 7, 10, 12. 5, yeah, 5, 7, 10, 12. 7, 10, 12, 15. I think this is not the one. Where is it? Oh well, my number is not right. So it's 4, 12, 17. Or maybe I forgot to. 4, 12, 17. So all the Y. 22, 24. So remember, don't mix them up. They have to be paired up with 15. 15 has to pair with 24. So this is a point. And then I want to look at this by zooming in. Is this a linear regression? This is quite linear, right? They kind of look like a line. So to do that, I will need to enter the second number, say y underscore 1. Go back up a little bit and then wiggly. Approximately equal to m times x underscore 1, because this is x1, y1, right? And then you do plus b. So you don't need to worry about R. Actually, R is useful in statistics, but we don't need to. We just want the line of best fit, and in this case is 1.971, usually 3 decimal places, negative 3.519. So that is our best fit line, and they actually graph it. You can see that this line go almost through all the points. You can use it to model the change of this data. It doesn't fit all the line, but it's a best fit. So I'm going to write it. I would say, just do a quick sketch, kind of like that, right? Does it linear related? Yes, linear related. If yes, write the linear is positive correlation. I don't think it starts from 0 though. Let me look at that. It start from 0 and 5 and then 20. So 5, so the 20 like that. So just do this. And then what is the equation? Y equal to, we don't have to say y1, 1.97 x plus minus 3.519. If they don't say anything, you use 3 decimals. 1.971 negative 3.519. Right, so that's how we can use it to predict y with x. So that's basically what you do. So in the second example, we say the U.S. Census tract percentage of persons 25 or older who are college graduate. And in every year. So in 1990, 1992, 1994, up to 2008, they are tracking how many percentage are college graduate. So is this trend linear? If so, find the line of best fit, round to 3 decimal places. So now it is very tempting to put 1990 actually into X, and then this is into Y. Now this is a percent. You do not need to change it back into decimal. This is good enough. But you do not want to use a big year. You might want to use t, because when we model t equal to 0, having a number is really nice. Otherwise, you have to find whatever initial value at t equal to 0. That's harder. So there is a advantage of using this t is equal to 0 and then put everything relative to 1990 as 0. So your t would be 0, 2, 4. Just subtract them. Enter these, and so this would be the x and this would be the y. Enter into the table of x1, y1. So I have pre-entered this in here. So let's say 0, 2, 4, 6, 8 to 18. And then let me double check that they're right. 16 is 20x, 27.7, right? So I pre-enter them. T is year since 1980. So build a nicer one, because then when you do your prediction, it's easier. Now we are going to do the second line of finding. Again, underscore, go back up by doing a right arrow, mx underscore 1, go back, right arrow, plus b. And then m is 0.476, and then that one is 20.746. So we would say it is, we didn't look at it. Wow, it's so close. So it is positive, right? Positive correlation. There is a trend, positive correlation. Very easy. You don't have to do any calculation. Y equal to 0.476x plus 20.746. Okay, if the trend continue, in what year would the percentage exceed 35%? Now this prediction would be used in between here, but you have to say, you have to project if the linear trend continue. So this is a percentage. That means I know the percentage. Y is percentage, right? So I would say 35 equal to what year? So that means t equal to what? So we'll do, I should use t. I should use 0.776t plus 20.746. Solve for t. So minus 20.746 minus 20.746. They're very easy to do. So that's why linear model is popular. When you use prediction or do this kind of problem, it's really easy to do. It's 14.254 equal to 0.476t, and then you divide 0.746 divided by 0.476. That would be equal to exceed. I should not say equal. I should say this. Okay, I should say this one. I should say this one greater than 35, right? Yeah, I should then do minus 20.746. I should do it this way. So I should just erase it and then do it again. As a inequality exceed 35. So it should be 0.476t exceed 14.254. So t would be greater than 29.94 after you divide 0.476. And so t is greater than almost 30, right? So in what year? So our basic year was what? 1990? 1990, my 29. So that would be the year when it exceeded 1990 plus 29.9.